Hello dear friends, welcome to my channels. Today's discussion two-phase method, okay? So friends, I have already discussed simplex method, okay? Simplex methods type 1 and type 2. Simplex methods are two type, okay? Simplex methods are in two type. This is type 1, another is type 2. So type 1 when all constants is less than equals to form, and when at least one constant. Type 2 when at least one constant greater than equals to form. So friends, I think that you know this is the type simplex method, okay? So this method, one method type 1 when it is type 1, okay? Then we used simplex method. We used simplex method. Now, when at least one constant form greater than equals to, we use two-phase or BGAM method, okay? BGAM method I will teach you, but now I teach two-phase method, okay? So then we use two-phase. This is the optimization technique, and this problem LPP is very important for BTech engineering and math honors BSc level, okay? So another is BGAM method, okay? So BGAM method. So let's talk about a standard form. Minimize, maximize z equals to minus 7.5 x1 plus 3x2 such that 3x1 minus x2 minus x3 greater than equals to 3 and x1 minus x2 and x3 greater than equals to 2. So you see constants are greater than equals to form. This is the greater than equals to form. So it is BGAM, otherwise two-phase method. In this video I will solve this problem with the help of two-phase method. So friends, this is the standard form. You see this is the standard form, and to handle it, we added artificial variable denoted by a, okay? This is the artificial variable. We added artificial variable denoted a in the given LPP for all those constants which are either greater than equals to 0, or equals to 0, okay? In this case we used artificial variable. So I think that you see that I use in here artificial variable, okay? This is my artificial variable a1 and a2. Now you see that I create a scheme. This scheme I use the simplex method. So you see whatever is the first number 7.5. So above this is the 7.5. And what is the x2? X2 is 3. And what is the x3? X3 is 0. What is the s1? S1 is, okay, in here we need s1 and s2. Okay, so no problem. In here you see s1 is 0. Okay, s1 is 0. Now a1 we get the, okay, in here we get 1. A1 is equal to 1, and a2 is, a1 is equal to 1, a2 is 0 and 1, and s2 is 0 and -1, and s1 is -1. Just putting the value all kind of this, and x3 is -1 and 1, and x2 is -1 -1. Just coefficient, just putting the coefficient. Okay, I know, I hope that you watch my simplex video and you can easily understand this topic. Okay, so this is the total my topic. Okay, so 3 1 -1 -1 -1, this is, and zj minus cj. Okay, zj minus cj is very simple, that zj minus cj is 3a1. For a1 you see in here it is -1 and it is -1, and it is in here -1. Okay, so a1 and -1 and a2 is -1. So this value is zj minus cj. This is in here it is 0, in here it is 0, and in here you get -4 -4 and you get in here 2 0. Okay, 1 and 1. Now you have to remember that how I can get this value, because I use in here phase 1. My target, what is the target? My target is phase 1. In case of phase 1, you see that it is changed. It is not 0, 7.5 and not, all the value is 0. Okay, so I have to put to this value, all the value is 0, because this is the procedure of phase 1. Now another factors I have to take, that I have to say the artificial variable technique is merely a device to get the starting basic feasible solution, so that the simplex procedure may be adopted as usual until the optimal solution is obtained. Okay, and you see in here, you see that identity matrix. Okay, whatever you see it is identity matrix. Now it is the total is clear for everyone. Now whatever I have to, I have to find out pivot element. Okay, so in here it is, this is my entering vector, it is my entering vector, it is the highest. Zj minus cj, I have already told zj minus cj is less than equals to 0, so I can easily find out this value. So now I have to find out mean ratio. Okay, solutions I have to write. What is the solution? Solution is 3 and 2. Solution is very important, 3 and 2. So mean ratio, how can I find out? 3 by 3 is equal to 1 and 2 by 2 equals to, so it is, you see that 2 by 1 equals to 2. So mean ratio in here, so this is my pivot element. Okay, this is my pivot element. Now I have to solve my way that I have already told that how to find out. I have to change the row, column, everything. So that I just divided everything, this row, with the pivot element. Okay, so friends, you see that Zj minus Cj, this vector is by pivot element, pivot vectors. Okay, uh, I just change my font size. Okay, you see that this is my pivot element. So you see this is the pivot element. This is my pivot element. Okay, pivot element, and entering vector, and this is my leaving vector. Leaving vector is a1. A1 is my leaving vectors, leaving vector, and entering vector is my x1. X1 is my entering vector. Okay, so now I just write in here Zj minus Cj. Okay, I know, I think that you will watch my simplex videos, that this is the process is simplex method, but it is phase 1, and now another process is phase 2. I will go phase 2 very soon. At first I have to, whatever I have to do, that what is my target? My target is, I have to my target is Zj minus Cj should be 0 0 0 0 0 1 1. Okay, so this is my target. So then I will change, I will go phase 2. Okay, that take a ratio of solution column with pivot column and choose the minimal ratio corresponding row is as pivot row. Okay, so this is my, so Zj minus Cj, and a1 is changing. So what is my a1? A1 is x1, because my entering vector is x1 and leaving vector is a1. Okay, and x1 and corresponding value is 0, and in here 3 is minus 1 by 3, minus 1 by 3, minus 1 by 3, 0, 1 by 3, 0 and 1. Okay, this is the x1. Now I have to change this value. How to solve? Because the same way, because pivot element this and this portion, and now let us draw a square. This is my square. I draw a square. Okay, just changing this point. So how can I change? Because 3 into 1, 3. Okay, and 0 into minus 4, 0, and divided by 3. So how would I get? I get this value is 1. Okay, this value is 2 is 1. Okay, no problem. Another method is the same way. I create box. Okay, just I am creating a box. Okay, again I create box with the green color. You see, this is the green color. This is my box. So 3 into 0, 3 into 0, 0, minus 4 divided by 3. Okay, determinant form. So the value is is minus 4 by 3. Okay, similarly procedure minus 4 by 3. Okay, 1 minute, another factor is 1 and minus 1. Okay, 3 into 0 0, and I multiply both. Okay, this is the minus 4 by 3. Okay, no problem. Another is this way. If I multiply, and this is the changing, I have to change this. So this is the 2, so 3 into 2 6. Okay, this is 6. 6 minus 4 divided by 3, so that this value is 2 by 3. Okay, this value is 2 by 3. Okay, another method is, you see this is the minus 4, so how to change this? 3 into, okay, so in here you see this value is obviously 0, because I make a unit. Okay, I make a ratio of the unit matrix. I need to find out unit matrix, so it is 0, and it is this value is a2, and this is 0. This value is 0, sorry, not 0, this value is minus 1. Okay, and next value, how to find out this value I find out, and this value I have to find out. This is a 0, and again I create a corner. So 3 into 1, so this is the 3, and 1 into minus 1, this is the minus minus plus 1 by 3, so it is 4 by 3. Sorry, this is 4 by 3. Similarly, if I find out this, so minus 3 into minus 3, this is the multiply, minus 3, and 1 into minus 1 plus 1, so minus 3 into plus 1 divided by 3, it is the minus 2 by 3. So this is the LPP formula, and this value same way, proceed the same way. This value 3 into 3, when I cross this portion, 3 into 3 and minus 1 into 4, so it is the 3 minus 4, this is the minus 1, so it is minus 1 by 3, and this value 3 into 1, 3 into 1, and 0 into 4 0, so it is 3 by, this value is 1 by 0 into minus 4 and 3 into 1. 0 into minus 4, 0 into minus 4 means 0. Okay, and 3 into 1, 3 divided by 3, so this value is 1. Okay, S1 and S2. Yeah, and 3 into 0, 1 into minus 4. 1 into minus 4 and 3 into 0 minus 4 by 3. Okay, So it is plus 4 by 3. Okay, plus 4 by 3, and in here it is 0, and this is a solution. Okay, another is this portion is 1. Same way, I am just putting the value. I don't have so much time to show. So this value is 1, and this value is minus 1 by 3, and this value is minus 1, and this value is sorry, this value is 1, this value is minus 1 by 3, this value is this value okay, I just okay, A1, and S2 value is, what is the S2 value? S2 value is minus 1, and this value is 1 by 3. So the procedure is same, because the corner side, corner means this is the pivot element, and pivot element, this is the element, so we multiply, and this is multiply. So we get this is the determinant form, and divided by pivot element. This is the row column operation. Okay, so this way I just get. So according to the way, so whatever I get, again I just changing my font size. Whatever we get, next step I am going to discuss in next step. If you watch my next step, then minus 4 by 3 is the less than 0. So in here x2 is entering variable. This is the entering variable, and in here it is the divisions. So I will just get this value. So this value is 3 by 4, and this is the negative, so don't need to solve. So whatever I get x1 and x2 again. Okay, in here not x2, it is the zj minus cj, it is zj minus cj, and x1 and x2 I get. Okay, x1 value is 0 and x2 value is 0. So friends, we see that we get same proceed same method. So whatever we get in here 0 0 0 0. Okay, how many zeros? So 5 zeros we get, and in here we get 1 1 0. Same method. In here I am just doing in here 0 and minus half. This is 1, and this is 1 by 4, 1 by 4 minus 3 by 4, and this is minus 1 by 4, and this is this value is in the case of solution, this value is 3 by 4. Okay, and this value is 3 by 4. Okay. So this is my entering vector is x2 and x1. Okay, x1 is same, I just fill all the values because I do not show the calculation is very simple. How to simple? Just create a square and find out the matrix determinant way. Okay, so the 0 and minus 1 by 4, minus 1 by 4, 1 by 4, and 1 by 4. Okay. So this value 5 by 4. Okay. So I get total value. Now I just copied this column. Okay, not this CJ, this column in phase. Now I discuss my phase. So whatever I get, that will I want to discuss with you, that I just copy. Okay, copy value is, it is 1, so x1 is my 1, it is my minus half, and this is 0 minus 1 by 4. Okay, s2 is minus 1 by 4. Okay, so don't need this portion I don't need to write a2. So this value is 5 by 4, 0 minus half, 1 by 4, and minus 3 by 4, and this value is 3 by 4. So whatever I see, you see that Zj minus Cj greater than equals to 0 for all j, and phase were terminate. Okay, BFS is feasible. Phase value, this in this case phase 1, I just terminate phase 1. Okay, phase 1 is terminate, this is terminate. Now do this terminate. Why BFS is feasible? Because note, since no artificial variable appears in basic variables. Okay, no artificial variable appears in basic variable. All the 0 is the 1 and 1. Okay. So in this way you see Cj equals to 0. So this terminate, this is my terminate portion. Okay, now I am going to solve this portion, and Zj minus Cj is very simple. You will find out. At first, x1 means minus 7.5 and minus, this is a 0. Okay, now this is a very simple way. Zj minus Cj means 7.5 into 7.5, 1 is 7.5 minus 0, so it is 0. And now you see half into 7.5 minus half into 7.5 and half into 0, so this value is 3 by 4. Okay, and this value I am just putting all the value, and 0 into 0 and 0 into 0, this is a 0, and this value is 15 by 8 and 15 by 8. So solution is 75 by minus 75 by 8. Now friends, it is a very simple, that I don't need to solve, because all of Zj minus Cj greater than equals to 0. I get my BFS. Okay, so hence my answer is x1 is equal to 5 by 4, x2 is equal to x2 is equal to 3 by 4, 3 by 4, and x3 is equal to 0, and mean z is equal to 75 by 8. Thanks for watching. I hope that you can understand. If you understand anywhere, please ask, call me. I will explain everything. So mean z is equal to 75 by 8 plus 75 by 8 mean z. Okay, mean z is, sorry, it is not mean z, it is max. Mean z is equal to 75 by 8 and max z is equal to minus 75 by 8. Thank review my talk. I showing you this is all my simple method, and this is a two phase.